So these ripples in space-time, it's like the echoes of cosmic collisions, right? When massive black holes merge, they leave behind these gravitational waves, kind of like it's like the chime of a struck bell.
Hmm. Right. And what's really fascinating is how we can actually decode these signals to, map out the intrinsic properties of black holes, like their mass and spin.
Exactly. In theory, once a merged black hole settles into a stable spinning form, it radiates a very specific pattern of gravitational waves known as quasi-normal modes or
Yeah,
QNMs.
absolutely.
Kind of like how a bell's sound fades in a predictable way, right?
Yep. But here's the twist. Back in 1997, theorists found a mode that didn't exactly follow that neat pattern. It was, well, a bit out of sync, which was really puzzling.
Exactly. They thought it might be a glitch in the models, but now new work from Hayato Motohashi suggests that this anomaly is actually two QNMs interacting in a complex, non-linear way.
That's pretty wild. So, basically, it's not just a single resonating tone, but more like a duet between different modes. That's a neat way to think about it.
Right, it's like two bells ringing together where each tone affects the other, creating a sort of cosmic harmony or dissonance, if you will, that reveals subtle details about the black hole's structure.
Yeah, I get that. And by examining these interactions, scientists can potentially derive more precise maps of the black hole's space-time geometry, sort of like, identifying imperfections in the bell itself.
Right, the imperfections, the slight deviations in the wave frequencies can signal asymmetries or even hint at new physics. It's fascinating because it opens up a whole new layer of understanding of gravity and black hole dynamics.
Absolutely. But if we think about it, some might argue that these interactions complicate our models. How do you reconcile that with the idea of neat, predictable fading tones?
That's a good point. I mean, it does challenge the traditional view, right? But isn't it like more realistic? I mean, the universe is rarely that tidy. The fact that modes interact could actually be a fundamental aspect of black hole physics rather than a nuisance.
True. So rather than being a glitch, it's a feature that could lead researchers to explore new territory in gravitational physics.
Exactly. And these findings, published in physical review letters, really pave the way for more detailed examinations of black holes. Plus, they might eventually help us understand if there's new physics hidden in these cosmic echoes.
Yeah, that's really exciting. It's like each gravitational wave carries a snippet of the black hole's biography. And by studying the rhythm of those snippets, we're reading a story written in the language of the cosmos.
Absolutely. And that story, with all its nuances, might be the key to uncovering secrets of the universe that were previously beyond our reach.
Exactly.